So today I'd like to give you our experience globally in terms of a test and integration aspect, which also includes use cases in Asia Pacific as well. So as mentioned, this test and integration is one of the key challenges for Open RAN. So there are quite a huge discussion about the benefits of the Open RAN itself, but the challenge is still there. So I'd like to discuss with all of you how we can take over these challenges. Okay, just a brief recap about the ORAN Alliance. So ORAN Alliance was created in 2018, and then now the 32 operators, as well as around the 300 contributor and then academic members. So as noticed, so recently, not only for industry members, but the academic members increasing a lot. So this means that the education to the students or research institutes are really important in this ORAN. If you look at the previous history, like internet or Facebook, those are coming from the university actually. But for this ORAN Alliance, starting from the operator's requirement, but now it's more like a stage for education and research in order to overcome the problem right now. And ORAN already released 3 releases. The first one is released in February of 2021, which is an open package, including open front door, open software. And release 2 was released in March of the last year, which is for intelligence, like a RAN intelligence controller, etc. And now release 3 was just released based on the November train of the last year, which includes the RAN slicing and SMO security. And now discussion for release 4 in ORAN Alliance, which may be energy saving, shared value, or massive MIMO, etc. So those are also coming. So ORAN is still continuing. So as mentioned, there are multiple challenges for ORAN still. For example, integration and interoperability overheads and the ownership for 4G and 5G, and also the field deployments. So of course, ORAN is not a network, but also the field testing is also required. And also multi-vendor integration between ORU, ODU, or OCU, ODU, or even LIC via E2 interface, A1 interface, O1 interface, O2 interface. So all this disaggregation bring new interfaces which must be tested well. And then, so security, energy saving. So those are also the key challenges to be well tested with the multi-vendor environment. And then also Open RAN is not only for open, but also virtualized. So this VLAN must be tested from a performance perspective as well. So as mentioned here, this is just a small list of the challenges, but as you can see, the many issues are still here to overcome. So this is the latest status about the ORAN Alliance for ORAN certification badging. So for example, this open frontal specification is, let's say, maturing for certification and IoT badging. The difference between the certification and the badging is the certification is produced to a node itself, like ORU or ODU, while IoT badging will be produced to a combination of the node, like ORU vendor A, ODU vendor B, and then IoT badge will be produced to those combinations. So that's the difference between the certification and badging. Why I'm mentioning this certification badging from ORAN Alliance is that this is strongly related to the OTIC, so Open Test and the Integration Center. So far, 12 OTICs have been approved by ORAN Alliance, and in South Asia, so Singapore OTIC was also approved. So, and here is the latest status about the ORAN Alliance OTICs. So 12 OTICs have been approved. As you can see, for European and then US also, China, Taiwan, Japan, and also the Singapore in the South Asia. And so far, let's say 12 certification badgings have been produced. but this is not still enough. It's not still enough. So I would like to expect more certification badging, and then more combination, more testing will happen in order to facilitate the open run environment. So BRB is a test and measurement and also optimization company. So we have a whole solution to test well and produce a certification and badging to promote more about Open Run. Yeah, this is our BRB's complete solution from end to end. You can test in each component or end-to-end benchmarking. So as mentioned that, for example, VRAN, virtual LAN, is a very has some issue about performance. So people would like to test from performance, which is better between traditional LAN and then virtual LAN. This must be tested well. And also security and the LAN intelligent controller. So those are actually the key to success to the ORAN Alliance. Open LAN. So let's go to the some new technology from ORAN Alliance perspective. So RIC, as mentioned, this is a key component to control the LAN. So without LAN intelligent controller, so MNOs or other vendor cannot control the LAN. So up to 4G, the LAN controller is, let's say, vendor specific. So there is no way to control via open software or operator requesting the software. That's not possible. It's still always specific to the big vendors. So for LAN intelligent controller, this is this is to achieve by rather than reactive, but be proactive. So checking the current status from the LAN and then control in advance. So that's the concept for LAN intelligent controller. So if we look at the 6G discussion happening in the ITUR, so by the way, the 6G vision has been produced by ITUR recently, and then now 6G requirements is under discussion in ITUR. But this kind of LAN intelligence, including data train, is a part of 6G. So this is technology is not only for 5G, but also 6G. So that's why this is a key component, even in 5G. So RIC is an open platform designed to host LAN control applications deployed by specialist software developers external to RIC vendors. So RIC also connecting to the apps, XApp or RApps, and fosters the innovation and speed, and then differentiates the network operator from competition. This is also the new thing, and mitigates the risk by testing. And here I just provide a small list. So what can be done by RIC? So for example, network slicing, so which is a new technology specified as part of 5G SA. And then, so network slicing SLA assurance is also possible dynamically using RIC, and also machine MIMO optimization in the configuration of the Open RAN. This is also possible by using a RAN intelligent controller. And energy efficiency. So this is actually new, as we know that there are many issues about power consumption globally. So this will be also the part of the 6G KPIs, while we didn't see the KPI for 5G for energy efficiency, but this is quite new and then the most important in this field. So yeah, using this energy efficiency technology by RIC, then operators can control and reduce the power, especially for ORU part, and also a VDU as well. And a PCI collision and a QoS/QoE control and a mobility load balancing, traffic steering. So those are possible and the new use cases by using LAN intelligent controller, and also geolocation intelligence. So this is also the key component for Open RAN. This is just a small list, so you can find out more and more new technology by controlling the LAN. Yeah, so from a BRB perspective, we can create a pyramid. So starting from the validation for the interface, let's say, so yeah, of course, in order to testing, then firstly, we need to follow the specification from all alliance for interfaces, like A1 interface between non-real-time leak and the near real-time leak, and O1 interface between SMO and then each node or near real-time leak, and also each interface. Those are the interfaces specified in the all alliance. And then starting from the interface validation, then the next step is the run scenario generator. So run scenario generator contains the run emulation as well as the UE emulation, core emulation. Everything is a part of the run scenario generator. So in order to test leak or RUP, XUP, you don't need any run. You don't need any UE. You don't need any core because firstly, you need to check and test the leak and also XUP, RUP firstly, then integrate to the real run. So that's the next step. Then the third step is the run application validation engine, AVE. So this is to perform the benchmarking between apps or runs. So operators would like to compare which run vendor is better, and generally. Especially for open run configuration, it's flexible, but it's quite difficult to check which configuration is the best. So that's why this kind of a validation is required. And then go to the data twin, which is also the part of 6G discussion. Yeah, so the next step, other than leak, so we see some security issue. So this is, of course, not only for Open RAN, but a global issue for telco. As you can see, the latest report, so communication is already start from top. The top security attacks, the education research, and second one is the government sector, and third one is already communication. So security attack is quite increasing recently. So there are multiple reasons why this is increasing. The first one is compared to the traditional telecom network. So 5G is based on the open architecture and agile DevOps. So this is quite different from the previous telco from in terms of a development perspective. And next one is a deployment. So in case of 5G, it's more like IT centric infrastructure rather than previous telco world. So code server, a VM will be used, and open software also bring us some security threat to be well tested. And the last one is the operations. So compared to the previous generation, 5G brought zero touch aspects for security, AI, ML, orchestrations. So those are also the security threat in 5G. So from an Open RAN aspect, ORAN Alliance, so ORAN Alliance security, working group 11 has specified multiple specifications, including a security threat model and security test specification and protocol specification. Many specifications have been already produced, but we must also test such a security using our BIB solutions. We have a complete solution for testing. So yeah, this is just a small list of the what's defined in the ORAN Alliance. So ORAN Alliance security specification also differ to 3GPP specification SCAS. There is many relationship between 3GPP and the ORAN Alliance. And the next use case is a network slicing. So network slicing is achievable by 5G SA. So this is also new. So what can be done by network slicing? So as you all know that network slicing together with the Open RAN configuration, so this will bring the very flexible configuration. For example, you can put the ORU only in the edge, or ODU ORU together in the edge, or even whole G node B can be placed in the edge. So whole the configuration is possible, or even UPF or MEC can be deployed in the local side. So this is also very important for Philippines. For example, you have there are many islands, so you can bring those edge component in the island, in each island. That's also a possible configuration. Yeah, thanks to the Open RAN configuration. But of course, with a flexible deployment, you need more testing from functional point of view or configuration or a performance point of view. So that's why case one, case two, I listed here with some possible configuration for testing, including a private network and public network handover. Those also needed. And then this is probably my last slide for a non-terrestrial network. So non-terrestrial network, NTN, maybe including hubs, for example. So this is also the key area for Philippines because there are many islands. This is applicable to Japan, for example. So Japan also that there are many disaster, so earthquake or tsunami. So that's why Japan government is strongly pushing. By the way, I'm from Japan now, so so some relationship. So NTN is quite a key area to support as a commercial network. So what's the relevance to O-RAN? So if we go to the O-RAN configuration with a non-terrestrial network, then you can have a flexible configuration. For example, you can put the ORU only in the hubs or Leo, Geo, or OCU, ODU can be also placed in the satellite. So that's a flexible configuration now satellite companies are looking at. So yeah, from testing aspect, we have a solution for this configuration validation and also the field testing. So by the way, field testing is also important because the Leo, Geo, maybe Geo is okay, but the Leo and the HAPS, the cell should be static, but it's still unstable. So maybe field testing is also required for non-terrestrial network. So yes, as I directly mentioned for this non-terrestrial network, so as you know that the several key stakeholders must be involved in this validation to be successful. So yes, we as PRB would like to facilitate this testing to be successful.